sound waves. So let's start with it. In the previous lecture, we have discussed about some properties of our sound waves. So one of the property of our sound wave is that how they can be produced and how they can be generated with the help of different what we can say by the different sources. Fine. So now we are going to discuss about how our waves can be generated out of those sources. Fine. So this is how we are going to see how the sound waves is going to travel through the different types of our medium. One is considered to be the solid, another is liquid, and third one is gas. As you can see, like from the solid surfaces or from the solid materials, your sound waves can travel more faster as compared to your liquid and gases. You can see like solid is going to have the densely packed structures. That is why we are going to say like atoms can easily transform their vibrations or energy through each other, and that's why we are going to say like sound waves can travel faster as compared to our liquid and gases. Now you can see like for the liquid there are very few number of atoms, so we are going to have the less speed of our sound waves in the liquid. And then for if we are going to consider about the gases, so gases, molecules and atoms are very far away from each other, so that's why we are going to say like speed of sound in gases is very less, or we can say like sound travels very slowly in our gases. Now, this is the another feature that should be discovered in our sound waves, that is called as echo. Like echo is considered to be a reflected sound wave. For example, you're going to clap from one side and you're going to have a surface on the other side. When you're going to clap on one side, so you can see, going to heard a sound wave that is going to travel the double of the distance from your source to the reflecting surface, and that is why we are going to cover the double of the distance. For example, the clapping source and the reflecting surface is going to have 75 meters. So when sound is going to again going to heard back to our source, if your listener is over here too, so you're going to cover the double of the distance, like 75 meters plus 75 meters, because you're going to hear the echo. You are going to consider the reflected sound waves in that case. So that's why you're going to consider double of the distance from your source to listener, and the time should be covered during this distance is going to be measured with the help of clock. So speed is going to be covered, like you are going to have the speed as distance over time. So 150 over time that is going to be taken by your stopwatch is going to be calculated the speed of your echo. Now how the sound can be seen, like if you are going to have a functional generator over here, it's also this is also called as signal generator, and this signal generator is going to produce the number of frequency waves, and you're going to have the very wide range of frequencies over there. Fine. So you're going to input all those signals to the loudspeaker, so you are going to convert your signal from signal generator into sound waves, and that can be heard by the loudspeaker. How you are going to see your sound waves? You are going to see it with the help of your oscilloscope. This oscilloscope is basically a digital graphometer that is going to show you the waveform of your sound waves, and is going to give us study about the frequency and the loudness and the pitch of our sound waves. So how the graphs of the sound waves can be seen on the screen. So this is the digital graph on the CRO scope. So how you are going to interpret it? For example, you need to understand about the two properties of sound wave. One is considered to be the pitch and another is considered to be the loudness. How the pitch can be calculated, like you can see pitch is relevant to our frequency, and if you can see from this graph, the first part of your graph, you can see there are higher number of waves that are going to be passing in 1 second. So you're going to have higher pitch over this graph. If you can see, like for 1 second you're going to have the lower number of vibrations, or you are going to see the less number of vibration or less number of waves passing in that second, so you are going to call it as the lower pitch sound wave. Fine. So we can label it as higher pitch sound and lower pitch sound. So you can also describe it with the help of your wavelength. For example, the shorter the wavelength of the wave on the trace, you are going to get the higher frequency of that sound wave. And you can see like here the wavelength is going to be very higher, so you are going to get the very low frequency of your sound wave. So this is low pitch sound wave and this is high pitch sound wave. So the more number of waves you can see, so you are going to get the higher pitch of your sound wave. Fine. So the another feature that I am going to describe is considered to be as loudness. You can see this is the graph of your sound wave that is going to be shown over trace, and you can see like its magnitude from its undisturbed position is very small. So you're going to get a very quiet sound in that graph, and you're going to get the louder voice in that graph. So we can see like the magnitude that is going to be covered from undisturbed position to the every peak of this trace is going to cover to give me an idea about my loudness. So this is louder voice and this is quieter sound or quieter voice. Fine. So if we are going to describe it in words, so we can call it as the larger the amplitude of the wave on the trace, I'm going to hear the louder sound of that. So the bigger waves you can see is the louder sound you can hear. So now we should know about the range of our hearing. For example, the human being can hear from 20 hertz to 20,000 hertz. So this is the audible range that human can easily hear. So similarly, the bat can hear from 1000 hertz to 120,000 hertz. So this is the maximum sound that a bat can hear. Similarly, the dolphin can hear from 150 hertz to 150,000 hertz. And similarly, the dog can hear from 15 hertz to 50 thousands of hertz. This is very small as compared to the other bat and dolphins. And similarly, the cat can hear from 60 hertz to 65,000 of hertz. And this is the basically maximum sound that can be heard by any cat. And similarly, the ultrasonic cat scarer can have the sound range as 20 kilohertz to 30 kilohertz. Now, the important feature of the sound wave that can be used as an application in our industry is considered to be the ultrasound. And ultrasound is basically any sound that is going to be ranges from above the range of our human hearing. That is, like, it should be above our 20,000 of hertz. So one usage of ultrasound waves can be used as industrial cleaning. Like if you're going to make any circuit board or any teeth or anything that is going to be used in any industry, so you're going to use ultrasound in that case. The second option that can be used by with the help of ultrasound is breaking down the kidney stones. So you can easily break down all the stones that are going to be occurred in our kidneys with the help of our ultrasound. The third usage is of industrial quality control. For example, if you need to detect any crack in a specific material, so you're going to shower the ultrasound waves over that material so that you can get an idea about your crack. The fourth usage is of prenatal scanning of your fetus. So this is also can be used as an in medical emergency to see the how the growth is going to be occurring. And the fourth is the range and the detection of the finding sonars in something that is beneath the surface of our. So that's all. Thank you so much. If you found any difficulty in this lecture, you can comment below so that we can get back to you.